Hi everyone, my name is Nicolas Dandrimont and I'm going to talk to you about the Software Heritage Project. So we're here, we kind of know that software is pretty much everywhere in like everything we do, everything we use has software in it these days. And basically software is a growing part of our scientific, technical, and cultural heritage. We're also free software people, so we know that the source code is kind of a special object in history. So the GPL license defines source code as the preferred form of modification for a given work. And basically, source code is executable and human readable knowledge. If you take a binary of hello world, it's just a bunch of bytes that you might be able to decode if you're really persistent, but it's not really understandable what's going on in this binary. But even if you only have a basic understanding of English, you're also able to understand that the source code does a print, so it outputs something, and probably what it outputs is the string hello world. So source code is special. And in the last 50 years, there's been an exponential growth of software. The Apollo 11 source code is 11,000 lines of code, which is 60,000 lines of code, which is like tiny. And there was no such thing as software engineering at that point. Software engineering was like this new Wild West that we had to conquer. Today, the Linux kernel is, I don't know, 20 million lines of code. That's an old figure. I guess it's around 25 million lines of code now. And like this source code is something that's like it's an excellent exchange medium for developers. Basically, it allows developers to understand what's going on with the software, and incidentally, computers can execute that information. Basically, source code is an insight inside the mind of the developer of the software. Source code is data. It's digital. It's bytes. And like all digital information, source code is pretty fragile. You can have like inconsiderate or malicious deletions of code if your infrastructure is not maintained properly. Your code hosting platform can disappear from one day to the next because it's not profitable anymore. And for obsolete code and for historical source code, you can even have physical decay of the source. If you have physical media in an attic, like magnetic media, well, they can decay and get lost over time. And we're kind of like, where is the archive that you can go to when GitHub disappears? Where is the archive, where can you find this code? And we're getting really close to a turning point where the people who built computer science as we know it are still around and can still be used to extract the knowledge about the history of software and the history of technology. And so, like, what we want to build is a universal platform that can be used for the past software source code, but also for all the future source code that's going to be written by humankind. So this is us. This is Software Heritage. Basically, our mission is to collect, preserve, and share the whole source code of all the software that's been written by humankind. So we want to preserve the past, we want to enhance the present, and we want to prepare for the future. So our core principles, basically we want to build like a base platform that's going to be used by lots of people. in the industry, for research, for education, but also for just the purpose of like keeping the data and making sure that it doesn't get lost, making sure that our heritage doesn't get lost. We do it with an open approach, 100% free software, transparent. Everything that we do is done in public on our Forge. And we do it in the long haul, so we do it replicated. We have a few agreements with mirrors to get copies of the archive that are not under our control and that I cannot delete by making a mistake when I'm tired at night. And we do it as a non-profit initiative. So basically, we build a foundation that's not driven by business interests. So if we do it right, we should be able to stay alive for a while. So the goal of our archive today is to target source code repositories and source code releases. For instance, tarballs that are published. So we do archive the contents of the files, the revisions, so Git commits or SVN commits, with all the metadata, the authorship data, the dates, etc., etc. We archive the releases, and of course we record where and when we've found all this data. And everything is stored in a canonical data model that's the same for all the version control systems that we support. We don't archive everything that's around the source code. We don't archive home pages or wikis. We don't archive issues. We don't archive mailing lists. Like, we know that this is something that's incredibly important, but this is like, we started somewhere, and we know that there's a lot of actors that do this right already. So our vision is to collaborate with them and play our part in like being one cog in the machine of something like a semantic Wikipedia or like, yeah, basically an encyclopedia of software where we could collaborate with the Internet Archive, for instance, to archive all the web parts that are around source code. So the data flow, basically we have upstream repositories that we list every once in a while, and all the sources that we find, we load them regularly as well, and we make sure that all the data is deduplicated, so we don't waste space. The idea is that we're gonna archive redundant sources. For instance, we are gonna archive forks of repositories, and those forks will share a lot of the data with the parent repositories. So we don't want to store 25,000 copies of the GPLv3 text file, for instance, because there's no point in that. So what we use to do that is a Merkle tree. So basically, it's a combination of a tree and a hash function. So basically every node in the tree is identified by a hash of the contents and of its children. So you can quickly check that something already exists in your tree. So this is what Git uses. This is what like blockchains use. IPFS uses that, and it gives you deduplication for free because you just compute the hash of your content. You check if you already have it or not, and yeah, and it also gives you integrity checking, so we can make sure that your data doesn't rot. So our archive, basically the leaves are contents. And then you have directories that are sets of files with names. And then you have revisions. Revisions are simply like a snapshot in time of a directory with an author information and a timestamp. And basically a set of branches, so a set of revisions gives us a snapshot of a repository. So for instance, for a Git repository, you'd get the list of all the branches pointing at all the commits, which points to their parents, etc., recursively. And this is basically the contents of the archive. So this is another description with like actual file listings and contents, and the idea of a snapshot with a list of branches. I guess it's pretty small on this screen. And basically, this is incremental, so if we visit the same repository again, and the list of branches hasn't changed, we only point to the same object. And if you add a new revision, then we expand the tree. But like we still point to the original data that we've found at the first visit. So the coverage of the archive, you can look at archive.softwareheritage.org. We have a bit fancier graphs on the homepage now. Basically, more than 6 billion unique source files referenced from all these sources, so GitHub, Debian, GitLab, and a lot of GitLab instances. Basically, every time we find a new GitLab instance, we try to add it to our infrastructure. We've also archived some repositories that have closed down, like Google Code and Gitorius, that we've been lucky enough to get like full archives of. And then we've started indexing and archiving like programming language package repositories like npm and pypy. So we're starting to like expand our coverage. We also allow scientific software developers to deposit their software. So basically, if you have a research article with attached software, if you publish it, so for now it's on the French Open Science repository. The French Open Science repository will push the source code that's been published with the article so that it gets archived in software heritage. Of course, we want to expand this initiative by like opening access to more repositories for them to push source code to us. So in numbers, around 400 terabytes of uncompressed source files, which is not that big because, well, it's all text files, which is small. It forms a graph that's 20 billion nodes and around 300 billion edges, which is like it's around the scale of some companies have graphs of the web, and it's around the same size. But the shape of our graph is a bit different than what the web has, because we have long chains of revisions in the histories. So we think that we have the richest public source code archive, and it's still growing daily. So if you want to look at the web interface, archive.softwareheritage.org. So we have a few like cool things to show. So the Apollo 11 source code has been digitized and put on GitHub. So basically, they took the transcripts from the MIT Museum and they scanned them page by page, and then they run OCR, and then they reread all the source code to make sure that the OCR process was okay. And so you can browse the Apollo software. If I move this to a new window. Come on. And I move this over here. And I zoom in. So yeah, basically you have the source code that's been used to land on the moon. For the 50th anniversary of the Apollo program, some people actually restored one of the original computers and made sure that they could run updated source code on the updated binary code on this machine. So yeah. So this is not too bad. I'm gonna continue. we all know that the Quake free source code has been published as a GPL as well. So it's on GitHub, and we managed to recover it. So we get some like interesting tidbits of what happened during the development of Quake free. For instance, you have this very fancy inverse square root computation function, which does some dark magic, and yeah, the person who came next wasn't quite sure what was going on here, but oh yeah, so you can search. So basically, the search currently is just in the URL of the repository that we've archived or the project. We are working hard to make sure that we can do metadata search. So basically pull the metadata from the repositories and make sure that we can search for that. We have a calendar view of the visits of the repositories. And then browsing, we've looked at that already. So in the backend, we use a lot of free software. We use Debian. We use Proxmox as a virtualization layer on top of Debian. We've started using ZFS a few months ago. We're quite happy with it for now. And we use Puppet to deploy all our software. So the metadata storage is done with PostgreSQL, which is okay. We're kind of having some growing pains because the database is starting to be around 7-8 terabytes with indexes, which is still quite manageable, but yeah, it's we could do better because the data structure that we have is like massively parallelizable, so we could do better than Postgres. The tasks, the task scheduling is done using Celery. We use Python pretty much everywhere, and we use Bootstrap and D3 for the web stuff. What we've developed in-house, the object storage we've written ourselves. The idea is that we didn't want to force our mirrors to deploy on something specific. So basically we have an abstraction layer, which is a very simple put-get interface. And then we have implementations for S3, Azure Storage, Ceph, and just putting the files on the plain file system. So this works pretty well. All the data model implementation, the listers, the loaders, the scheduler, everything is written in Python by us. So this spans 20 Python packages, and the deployment is around 30-40 Puppet modules. It's not a very big code base. We've tried to make sure that everything that we do now can run also in Docker, so you can actually run your own software heritage like model thing, so you can actually get into the code and start submitting patches. Everything we do is copyleft, at least for the backend stuff. For the Puppet stuff, we use the Apache license because that's what most of the Puppet ecosystem uses. And so we try to be friendly to the rest of the ecosystem so that we can cross-pollinate stuff. So the deployment architecture. So at the bottom we have our object storage, which only stores the source code files. And then the metadata storage is in a PostgreSQL database. So basically the graph storage is split between metadata and actual data. And then the main components are the lister, loader, and indexer workers, which talk to a Celery broker, which is basically RabbitMQ. And so the scheduler component has the list of tasks that are recurring, and then we have two small components that just push and pull to RabbitMQ from the database. Because we've had some issues with celery and reliability, like if you want semantics where you're sure that all your tasks have been executed. Like it's not. We've had issues when putting 100 million tasks in Celery itself. So we've tried to just use the broker as a buffer, make sure that all the information about the tasks are actually stored in the database. Maybe we're just doing it wrong. It's something that we've had to do. Hardware, a few hypervisors, one main database server, and then some replicas as containers. Two dedicated storage servers using blank ZFS these days. And we have high-density storage arrays, which are basically big boxes full of hard drives. And we've got some sponsorship from Microsoft, which allows us to run a full mirror of an infrastructure on Azure. We also put some workers there, but we only use Linux virtual machines so that we can deploy them anywhere else that we want by just changing the deployment manifests. We don't want to get locked into a cloud provider. So we make sure that all the data that we generate gets sent back to our own infrastructure, at least for now. Everything is done through classic FOSS development practices. We do everything in English, even though almost all of the team is French. We have a public development mailing list, IRC channel, source code and code review on a Fabricator instance. And yeah, that's it for the overview. So what happened lately in the project? So last summer we had a very successful Google Summer of Code session. We had 3 interns who worked on different parts of the project. So one of the interns, Archit, worked on increasing the coverage of the archive. So basically, he worked on making sure that we had listers for new upstream repositories. So we introduced Crown Lister, which is the repository for R modules. He has rewritten the lister for the GNU project, so we can get all the source code from the releases of the GNU project. And then he's refactored the listers for the Node.js and Ruby ecosystems as well. And I've not finished that phrase, which looks silly, but anyway. He's also worked on making sure that the loaders use the same base code. And so, introducing a loader for a new upstream repository is just overriding a few methods to actually look at the metadata in the right place. And everything like untarring the tarball, generating the manifests to load in the archive is just hidden under the hood. So loading a new language ecosystem, I don't know, Perl for instance, would be just a few dozen lines of code. Kalpit, another intern, worked on a web frontend, and the major thing that he introduced is end-to-end testing of the frontend. So basically, it's a JavaScript module that's called Cypress, and basically what it does, it instruments a web browser, and it allows you to click and to record what happens on the page. So you have a full test of all your JavaScript and all your interactions with the server without a single click, which is quite nice. Because we are starting to have a lot of features, and it's hard not to break those features by changing stuff in the backend. So yeah, having integration of web QA is really good, and so we're glad that he had the opportunity to work on that. And the last intern, Thibaut, worked on graph compression. So it was more of a research-focused internship. Basically, the idea is that we have tens of billions of nodes and hundreds of billions of edges in our graph. And so if you store them like naively, you can't fit everything in a single machine, at least not in memory. And so lookups and recursion is really slow. But the people who have worked on like crawling the web have done a lot of work in making sure that you can compress graphs of a very large size into some manageable memory. And so I think the results that he's managed to achieve are being able to store the full graph of the software heritage archive in 300 gigabytes of RAM, which is tiny. It's like you can have that on a single machine, one U server. And then you can do very fast algorithms to do large-scale analysis on a single machine, which is useful when you're only like if you're a research team and you don't have lots of resources, it's useful to be able to work on a smaller scale than having a huge Hadoop cluster running in a cloud and spending tens and tens of thousands of euros to be able to do a join between two tables, because the algorithms in these things are crap and you end up scanning all the data to just do a simple join. So basically, yeah, this is the basis for a new toolkit that we are going to put out for helping the scientific community analyze source code in large scale, which is one of the things that we really want to enable. So I've talked about replication earlier. We've signed mirroring agreements with two partner organizations. So FosID is a Swedish company that's focused on license compliance in the open source world. So basically making sure that companies know the licenses of the software components they use. And ENEA is the Italian National Agency for New Technologies. Basically, they're the former Atomic Energy Commission of Italy. So they're a public institution, and they want to support actually the work on software sustainability. And so our infrastructure will be based on, is based on Kafka. So Kafka is a basically a message bus, which is like fully distributed. You can scale it as you wish. One of the big deployments of Kafka that I know is in the Wikimedia Foundation. Every event that happens on the Wikimedia projects is pushed to a Kafka cluster, and then clients can subscribe to events and get them real time and make sure that they can like trigger actions on events that happen at the scale of the Wikimedia projects, which is fairly large. So basically what we do is we push all the types of objects to different topics as soon as they're added to the archive. And this allows either to build a full replica of the archive. If you just start at the beginning and replay all the objects, then you can get the full graph. Or you can just subscribe to some object types. For instance, if you're interested in, I don't know, analyzing the language in Git commits, you can just subscribe to the revision topic and read the messages and do whatever you want with them. So this is a work in progress in a sense that we have the tools that have been built, and our partner organizations are building their infrastructure on their side, and we're going to push the data with them soon. And finally, we've worked on improving what we do on preservation. So in February, we published the Paris Call for Software Source Code as Heritage for Sustainable Development. So it's a mouthful, but basically it's a simple call. I think it's like 20 or 30 points to raise global awareness of the importance of preserving software in general and source code in particular for sustainable development. Basically, it's like I think there was a meeting with 40 experts on preservation on software, and they agreed to like call on the global community to make sure that software source code was treated as the important object that it is, because everything that we do in society today is mediated by software in one way or another, and it's very important that we make sure that this software isn't lost and is understandable by the people who use it. And lastly, what we did a few weeks ago, so in collaboration with the University of Pisa, we have published the Software Heritage Acquisition Protocol. So basically, what we had done so far was trying to do not the easiest, but well, kind of the easiest thing that we can do to archive software is just putting every single piece of software that's publicly available and putting it in one place. That's nice, but there's a lot of software that's just not publicly available. There's a lot of software that's rotting in an attic in a university somewhere. There's a lot of stuff in museums that isn't really exploitable by the public. And so with the University of Pisa, who has a lot of artifacts from basically the history of Italian computer science. They have stuff that dates back from the 50s of all the computers that have run in Italy since the beginning of computers. And so we have worked with them to put in place a process of collection, basically making sure that people can digitize the software and put it in an exploitable format. And then collection, which means allowing Software Heritage to pull the source code and protect it. And of curation, which is making sure that the meaningful historical source code is like well published and is exploitable for everyone. So all these new things, when I publish the slides, there's going to be links on the slides. So if you're interested, you'll be just able to click the links. And so that's it. We have a Wayback Machine for source code. This is a huge reference catalog using intrinsic identifiers for software. People can deposit their source code, and we're building like the universal knowledge base about source code. Much more is in store. I've talked a lot about that. So thank you. This is Software Heritage. We're open, so if you're interested, I have 10 minutes for questions, or if you want to know more.
What do I have to do if I want to contribute code to it?
So, if you want to contribute
to the archive, not to the
right, yes, I understood. So right now we have the ability. Well, so we have a Save Code Now feature that currently only works on repositories, so Git, Subversion, or Mercurial. I think we should be able to actually move it to also allow tarballs of software. So basically you put the URL. There's a simple review process done by administrators to make sure that we can download and redistribute the source code, and then it ends up on the archive. So if you go to archive.softwareheritage.org, there's a Save Code Now button that you can use.
So at the moment it only works for version control systems?
For now, yes.
Okay.
We've been discussing adding the possibility of submitting tarballs as well.
That's what I would have, because at some point I noticed that some software I was using in the past vanished from the net. It's maybe only in the Wayback Machine of archive.org.
Right.
And I pulled myself a copy because I wanted to keep it.
Yeah.
Same intention. And I'm glad there's another place which is much better suited than my web server.
Right. So yeah, like actually there's a vacation period right now in France, but just after some of my colleagues left for vacation, they were just completing a refactoring of all the loading machinery. And after that, we should be able to add tarballs to the Save Code Now interface. So you can just, and you can even automate it by just like it's a REST API. I'm gonna manage. So you can just submit source code. For instance, the French digital agency has like registry of all the open source projects that are developed by agencies in France, and they use our Save Code Now feature to make sure that when they detect a new repository, it's archived in Software Heritage. So they push Save Code Now requests so that we trigger download of all these repositories.
What are you doing in terms of curating the archive? So is it more about just collecting everything, or also do you kind of say, no, that's something that's too small, too unimportant, we don't want it?
Right.
And do you kind of support or have additional context data about what you collect, like the Apollo 11 software, how it was created, in which context, or who did it, or whatever?
Right. So we don't currently do any curation ourselves on the archive. So basically, we focus on mass collection of the source code with the idea that, for instance, if you consider that a JavaScript module that just adds spaces to the left of a string is not important and you don't archive it, the day it disappears, half the internet stops working. So you can't really tell from the get-go whether something is relevant or not. And at least that's a responsibility that we don't want to take. Your second question was about additional context around the source code. So we've started working on collecting the metadata that we can get automatically from hosting repositories. So for instance, we would get we're not quite there yet, but we want to record, for instance, the keywords and the description of the repositories in the upstream hosting platform, and allow this data to be searched, as well as just the link that's been used for archiving the software. However, we don't want to replace Wikidata, for instance. So what we do is we collaborate with people who work on Wikidata, and we make sure that there's a Wikidata property. I think it's software heritage release or something like that. So basically, you can you can reference artifacts on software heritage on Wikidata. So you can add link from Wikidata to software heritage, and we also collect the backwards link. So we make sure that we cross-reference this. And so once you've connected with Wikidata, you can add more contextual information on Wikipedia and then cross-reference with Wikidata. So we don't want to do everything, but we want to actually cross-reference with relevant projects because we're only 14 people in the team, which is already quite a big team, but it's still quite small. So we don't want to do everything ourselves. We'd rather collaborate with relevant projects.
Which has been the biggest difficulties or challenges during these years on the software heritage project?
So I think the biggest challenge that we have is that source code is tiny. The files that we archive, I think the median size of a file is 3 kilobytes. And so it doesn't even fill a disk sector these days, which means that storing several billions of those tiny files is a really big challenge. We come to the limits of file system performances or even object storage facilities. For instance, we've done some experimentation with Ceph. Ceph is optimized for multi-100 kilobyte objects. Basically, if you want redundancy and erasure coding, you end up striping your data across multiple disks. And so you take the size of one sector on one disk and you multiply it by the stripe width. And so for every file that's 2 kilobytes, you store 320 kilobytes of blanks in your system. So you get kind of crappy, so you get into crappy edge cases with that. And we don't really have a very good solution yet for that.
What hash functions are you using to catalog the software? And have you found ways to up the performance of calculation?
So for the leaves, so for the actual contents of the files, we use SHA-1, SHA-256, and Blake2S256, as well as the Git salted SHA-1, so the SHA-1 with the Git object header in front. For the rest of the objects, we use Git compatible identifiers, so basically SHA-1s with a header, SHA-1s of a manifest of the object with a header in front. So we are not too worried about collisions because for the contents, which are the objects that are really easy to manipulate, we use several hashes. We've not actually done anything regarding performance of hashing objects. Most of the stuff that we hash is really tiny. It's like a few kilobytes of metadata. So no, I don't have anything that we've done around this.
Yeah. So. Have you looked into using Swift as well?
No.
Because I know it's not there yet, but they are working on storing small size files or objects, concatenating them into a larger blob. So that might maybe one solution. Right. And I know it goes up to the scales you have, like 300 petabyte is not uncommon in the Swift cluster.
Right. Yeah. I've actually attended a session at FOSDEM last February with the people from OVH who work on this object packing feature of Swift. We've not actually tested it yet. It's. I think it's one of the avenues that we should actually look into because it looked promising when we looked at it. The main issue we had with it is that it wasn't upstream yet. I've not checked since. I've been busy. So yeah, that's still something that we need to look into. Thank you. I guess we're done.
So thank you, Nicolas, for your talk about software heritage, and I think that's worth a round of applause.
Thank you.